My name is Russ Sorrells. This is the CapEx IndustryCast. So excited today to introduce Matt Matheny. Matt Matheny has joined our team, and he has extensive background in helium or tracer gas technologies. So we thought it would be a good intro to Matt, to our audience, and then him to be able to add some immediate value given his many years of tracer gas technology experience. So he's had experience as a manufacturing engineer, working with tracer gas technologies, hard vac accumulation systems, and then he's also had extensive experience working with Inficon for 6 years, working through and seeing many applications for tracer gas technology. So we are fortunate to have Matt on the team, especially with his special knowledge on this tracer gas technology. So today, what's going to happen is essentially, I'm going to try to pick Matt's brain, and hopefully with that picking of Matt's brain is going to help our customers better understand when to apply helium technology, hydrogen technology, tracer gas technologies for your leak test applications. We'll say, based on my 20+ years of leak test experience, without a doubt, tracer gas technologies are the most reliable as it relates to repeatability and confidence that what the answer is tells you whether your part is good or bad. And that's really what we're looking for when we are performing any type of leak test. The challenge that comes with tracer gas technologies is they can tend to be expensive and complicated or complex. It's a special knowledge to troubleshoot and work through. So those are some of the challenges that we face when applying the technologies. But if you want certainty in your testing efforts, tracer gas technology will give you a level of certainty that no other leak test technology can offer. So with that, I want to again introduce Matt. If you just Matt, explain some of your background. I kind of gave it there, but what are your thoughts on this technology? So again, welcome to the team.
Yeah, thank you. Glad to be part of the team. Yeah, so my background with tracer gas leak detection goes back to the year 2000. Hopefully I don't look that old that I have 21 years worth of tracer gas leak detection, but got some gray hair going, so maybe. Yeah, I worked in manufacturing, both in the automotive industry and the air conditioning industry. And in both companies I worked for in those industries, we use tracer gas leak detection. In automotive, the company I worked for was making fuel tanks and also fuel modules, which is a fuel pump, level sender, all kind of built into a thing under a flange that drops into a passenger car fuel tank. And at that factory, we used helium hard vac leak detection technology on both the tanks and some of the fuel modules. In the air conditioning industry, a lot of tracer gas is applied as a sniffing application. So that you charge, whether it be a little air conditioner for your house or a huge, hundreds of tons chiller that's the size of a large semi truck, you would charge the unit with a tracer gas to some positive pressure, and then you would take a sniffer probe and go joint to joint to test each braze joint or gasket joint or weld joint on that unit to make sure it's not leaking before you charge the unit with refrigerant.
Oh, wonderful. Yes. I mean, you 21 years, holy mackerel.
I know. I feel very old saying that.
So yeah, for sure. That's very good. Well, I'm going to launch this presentation right quick, just so we can kind of have a list of, or a guide, I should say, for us to utilize here. So, really, again, this is going to be questions and answers where we're just going to try to offer some perspective to help customers really understand when should I apply, what is an appropriate application for technologies, what should I expect with these technologies. So I'll just try to ask some questions along the way. that could trigger that. So just this is our only real marketing that we do in these industry casts. We want to remind our customers who we work with. So at CapEx, our focus is building relationships. That's what we're all about. We want to be adding value to our customers at every opportunity. That's why we do these industry casts. Again, it's just to add value in a small way to help you be better at your role and in your career. That is our mission. We represent ATC Automation out of Cookeville, Tennessee. I always talk about 85% of their business is with repeat customers. That is huge because there are a lot of companies out there that are one and done, but ATC Automation follows through. And as a result, our customers come back time and time again. So that's why that statistic is so important to consider when choosing an automation company. Cincinnati Test Systems, the largest leak test company in the world. This is how actually Matt and I got to know each other many years ago, was working together when he was at Train, working on leak test applications. So Cincinnati Test, just so proud of what they have become and the company that they are, really customer focused, customer oriented. Duquesne Plastic Joining, again, a customer focused, customer oriented company. Everything plastic joining, hot plate welding, vibration welding, ultrasonic welding, spin welding, laser welding, hot gas welding, all things plastic joining. That is their focus, and that's what they are extremely capable and competent at. Symetric, we break them out. They are a division of Cincinnati Test Systems, but we break them out because their focus is on high-speed in-process data and test management. So Industry 4.0 is what you want to think of when we're thinking Symetric. And then Keller Technologies right there in Fort Mill, South Carolina. They do industrial air filtration, wet and dry filtration. So, all right, that is the commercial that we talked through. So at a high level, Matt, Tracer Gas Technologies, tell us about sniffing, tell us about accumulation, and tell us about hardback.
Yeah, and then there's sort of a fourth category, which I would say miscellaneous weird applications. But these are the main three that you'll typically see in manufacturing. So Sniffer is, I sort of explained it before, you charge whatever it is with whatever you're testing. It could be a gas meter, it could be an air conditioner, it could be an automotive component, it could be a pacemaker, it could be any sort of thing that needs to be leak tight. You would charge that part with a positive pressure of tracer gas, which is generally helium or diluted hydrogen. And you have an operator or occasionally a robot take a sniffer probe and go to all of the potential leak paths on the product. So say you have an automotive component the size of my fist and it has a weld around it, your operator would take a sniffer probe and probe around that weld. And a good thing about a sniffer is compared to other tracer gas technologies, it's less capital investment to get into it. And it offers something that accumulation and hard vacuum do not, in that it not only tells you if you have a leak, it can pinpoint where the leak is. So not only can I tell if I have a leak on this weld joint, but I can tell by where the sniffer is alarming when I move the probe exactly where the leak in that weld is. So that's sniffing in a nutshell.
Yeah, and speaking of shells, we have a special technology that has been developed at Cincinnati Test Systems called the clamshell or purging clamshell technologies, where we create an atmosphere of a clean atmosphere using nitrogen to allow us to more accurately detect a tracer gas leak out of a joint. So we would take a clamshell of sorts and
yeah,
so,
I'll do a demo here, Russ. I got a marker. Oh, there you go.
Right on.
Yeah, so in an air conditioner, you have braze joints on copper tubing, right? So pretend where it goes from white, blue here, this is a braze joint. We can actually encapsulate that joint and take out the effects of any background tracer gas in the area and do a really a better test than you could just with an operator moving a sniffer program around this joint by really controlling the volume and the atmosphere within that clamshell.
Yeah, so it's a high. It's almost like a sniffer accumulation combination, right?
Mm-hmm.
With lower cost than a big chamber that we would normally think of for utilizing an accumulation technology. So with that, talk to us about accumulation.
Yeah, so accumulation is somewhere between a sniffer and hard vacuum as far as complexity, sophistication, capital cost. It is when you put a part that's either charged, or you put a part and then charge it in a chamber, then you stir the volume of air around the part to get a good mix, and you look for a tracer gas rise over time, rise in concentration over time, and you can correlate that knowing the free volume in the accumulation chamber and the amount of concentration rise. You can correlate that to a leak rate.
What's a drawback to accumulation?
Accumulation is not as sensitive as hard vacuum can be. Mm-hmm. So there are certain applications where it can't be used because it can't achieve the leak rate that is needed for a particular part or assembly in the allotted cycle time. But things that have a leak rate that are more like an automotive radiator, some power steering hose assemblies, things like that, that are the leak rates, too low to really get away with using an air test like pressure decay or mass flow, but you don't quite need a hard vacuum for. There's accumulation is a sweet spot for those applications.
Yeah, you make a good point when you're talking about radiators, because with radiators, they have a 3 standard cubic centimeter per minute reject criteria, at least that's been my experience. So in theory, you should be able to use pressure decay leak test technology with confidence on a 3 SCCM leak. Here's the problem. When you use pressure decay, when you use mass flow, you're measuring pressure change in the part, right? So if you have a radiator, which is meant to do what?
Exchange heat.
Exactly. So any breeze across that radiator is going to change the pressure inside the part, therefore make your pressure decay all wacky. So you can save your sanity, go away from using that technology and applying helium or accumulation to take that on. But go ahead, you got.
Yeah. There's another point to be made there too. A lot of the components that are made, radiators, you may run it through a furnace. It's an air conditioning component. It's just been brazed with an open flame torch. A lot of those components in the manufacturing process right before leak detection have a lot of heat put into them. So they're naturally going to lose pressure because they're going to be exchanging that heat during the pressure decay test cycle, for instance. So, that's something that's really hard to deal with if you're trying to just do a pressure test.
Yes, absolutely. And it's another hard part of it is it's way more expensive to use accumulation than it is to use pressure decay. So it's difficult for our customers sometimes to wrap their mind around it. But at the end of the day, from a sanity perspective, if you want to make certain that you are sending parts that are good to your customer, then moving away from the pressure decay mass flow technology and those type of applications is a more robust and repeatable strategy moving forward for your customers, protecting them, and then for your sanity, quite frankly, So next is hard vacuum. Tell us about that.
Yeah, that's the cream of the crop. If you want absolute certainty that your part's leaking above a set leak rate or not, and it's also the ultimate in sensitivity. When we get into tracer gas leak detection, we often have to, for the application, describe the leak rate we're looking for in scientific notation because there's so many zeros after the decimal point. So if you hear someone who's got a lot of experience with tracer gas leak detection, they'll talk in decades. So they'll say a -5 leak, -6 leak, a -10 leak. If you're not used to tracer gas, that goes right over your head. You don't understand what they're saying. So often we measure tracer gas leak rates in millibar liters per second or atmospheric cubic centimeters per second. So if you think of an atmospheric cubic centimeter per second, it's essentially the mass of gas that occupies 1 sugar cube of volume at atmospheric pressure. So that's what an atmospheric CC is, and then 1 of those leaking per second.
So what is atmospheric pressure? Like right now, what is atmospheric pressure?
I don't know what elevation I'm at or you're at, Russ, but it's around 14.6 something. If you're at sea level, it's around 14.7. PSI-A.
What a lot of people don't know and don't realize is that we are always experiencing pressure, and that to not experience pressure would be a bad thing. But
yes.
So the pressure that we experience just naturally is 14.7. So when we talk about absolute or gauge pressure, we take those 2 into consideration. So we don't need to get in depth in that right now about the difference between absolute and gauge, but it's just interesting to remind everyone that we are always at 14.7 or 14.6 something PSI, depending on the elevation that we're at.
And the cool thing about hard vacuum is you can go way super low leak rate to the point where it's really even hard to imagine the size of the leak. So
that's a great point. You put it underwater. Like how many years is it going to take for a bubble to develop on some of the stuff underwater, right?
Exactly. So if you look at the refrigeration industry, they have a leak. They express their leak rate as 1/10 of an ounce of the refrigerant per year. If you look at air conditioning, it's typically 1/2 ounce of the refrigerant per year. And when you do that math, you get into the -5 or -6 range for a tracer gas. So -5 range meaning 0.00001 atmospheric CC per second.
Well,
so,
which is
yeah, so that's a leak that if it was a hole, you couldn't see it with your naked eye. And usually those leaks you cannot see, so it's not a visual inspection. And also in that -5, -6 range, if you were to charge the part with air and put it in a dunk tank, which a water tank, which is the old school way to leak test, right? You would not see a bubble for at least 20 or 30 minutes if you see a bubble at all.
Wow.
And I can share videos of what that looks like. We have that available if anyone wants to see that. But so I'm talking about -5, -6, but hard vacuum can go all the way to -12 and beyond.
Yeah, yesterday we were about pacemaker batteries. Where are those tested?
Those are tested to at least a -10, so 9 zeros after the decimal point, and some are tested, I think, to the -12.
And what is, and I should know this off the top of my head, I'm asking you, and I don't know the answer to this question, but what is the level of helium that naturally occurs in our atmosphere? So if we were to just take a measurement, how many decades, what is that going to be?
Yeah, so that's a really good point. So there's some debate over the etymology of the phrase tracer gas. And one of the theories is we say tracer gas because we're using a gas that is a trace element in Earth's atmosphere, in normal air that Russ and I are breathing right now. So you can't use things like nitrogen or oxygen as a tracer gas because there's so much of it in the air, and you're looking for a very small leak, and there's no detector that can measure that small change. Nitrogen is what 800,000 ppm in the air that we breathe. Yeah. And a small leak like a -5, we're looking for a fraction of a ppm. So trying to distinguish a fraction of a ppm in a 800,000 background signal doesn't work.
I always explain to people it's kind of like trying to measure a drop of water in an Olympic-sized swimming pool. You know, I mean, it's just you're not going to be able to measure that, you know, single drop of water. And so that's what background. That's why background, minimizing background in so. Right?
So you have to use something other than water because that's the background. So using your analogy, which I've actually not used, I like it. If your leak is a drop of food coloring, you can probably see that in a pool.
That's a good point. Yeah.
So think of, so tracer gas, we're using things that are very rare in Earth's atmosphere. Helium, the natural background in helium in Earth's atmosphere is 5 ppm. So a detector looking for 0.1 or a half a ppm change, essentially, in a 5 ppm background isn't that hard compared to 800,000. 5 is much easier to distinguish, right?
Yeah. And you make it so much easier when you're trying, when those ratios are correct, right? Mm-hmm. Otherwise, it's near impossible, and you pull your hair out, or you lose your hair, you know, as a result. So,
and then some tracer gas, yeah. Well, let's talk about hydrogen for a second. So, natural background of helium is 5 ppm. Natural background of hydrogen is actually 0.5 ppm, a half of a ppm.
Wow.
So the natural background is lower than helium. However, you can get caught a little bit there. So natural background is 5 ppm, and that's somewhat easy to control because there's nothing in an industrial environment that creates helium. If you could create helium, helium would be cheaper than it is. It's mined out of the ground as a byproduct of natural gas extraction, mostly currently. There's not an easy way to man-make helium without a nuclear reaction. And obviously there aren't gas companies out there that are going to buy a nuclear reactor to make helium in small quantities. So, so the natural background of hydrogen is better. There's two problems with that. In an industrial environment, there are things that can create hydrogen. Manipulating aluminum can create a hydrogen signal. Forklift exhaust has a hydrogen signal in it. If you have industrial washers with burners on them, there's things in manufacturing that you have to be careful with, that if you're going to consider hydrogen as a tracer gas, you have to make sure that you have your background under control.
Yeah, that makes sense.
So when people think of hydrogen, or, you know, I first suggest hydrogen to a potential customer, I think everyone thinks, oh, the humanity, the Hindenburg, right?
Yeah.
So how hydrogen is applied as a tracer gas is we actually dilute it with nitrogen. And that mix is 95% nitrogen and 5% hydrogen. And at that point, you can treat it just like an inert gas, just like nitrogen or helium. There's no problems with flammability. The only problem there is you have a 20-to-1 sensitivity difference between helium and hydrogen, because with the hydrogen leak test, if we're using diluted hydrogen, we're only counting or detecting 1 out of every 20 gas molecules that leak out of the part. Whereas with helium, you can use 100% helium and have greater sensitivity. So it's sort of like back to the accumulation. Hydrogen fills a nice niche market in the middle range of leak rates, where you may have a test where pressure decay or mass flow is not sensitive enough, but you don't want to go all the way to helium, which is a little more expensive than diluted hydrogen. So it's a nice fit for certain applications.
Okay, excellent. Now, what other? So we've talked about helium, we talked about hydrogen. I mean, there are a number of other tracer gas technologies that you've enlightened me about, but I wasn't aware of until you did.
People, especially in the air conditioning refrigeration industry, will actually do a leak test and use refrigerant as a tracer gas. So they'll put a little bit of refrigerant charge in the unit, and then they might put some nitrogen or air on top of it to increase the pressure. So this is problematic. You don't want to mix or dilute your tracer gas inside the part. Gases don't just magically mix well or mix instantly. So that's a bad idea. And the second reason that's a bad idea is refrigerant's actually considered a super pollutant. So you don't want to use something as a pollutant as your tracer gas, because then you're venting that into the atmosphere, and that's problematic for climate change, global warming, all that kind of thing. So there's always someone, at least once a year, someone asks me, can I use xenon or neon or just some wild gas? And you could. There are mass spectrometers that can detect those gases, no problem. But those things are just so expensive, and there's really generally no justifiable reason to do it.
Yeah. Well, let's kind of wrap up here talking about different applications. I'm sure you've seen hundreds of applications. These are just a smattering of some of those. What I left off here is one of the biggest markets is the HVAC, and that's where your expertise comes into play, and we'll be talking about next week specifically the latest requirements for that HVAC industry. But we talk about gas tanks. You mentioned gas tanks coming on, and the gas tanks are a very unique animal as it relates to leak testing, because there's so much volume. You're putting them in a hard vacuum chamber. When we talk about hard vacuum, we're talking, millitors of pressure inside that, right? Because we want to evacuate the atmosphere around the part, because that makes it easier for us to detect helium that is escaping. So what we have to do with gas tanks is, when we're pulling a vacuum, if we just pulled a vacuum on the chamber, the tank would crush itself, right? It would just go down to nothing. So it's tricky, because we have to pull those down simultaneously. So we pump down the chamber, pump down the part simultaneously, and then backfill the part with helium to create, ideal. I think about a 2 psi pressure delta is what I remember that you typically would shoot for there. And so those are complicated. Not as low a leak rates as like an airbag. Airbags, of course, they have to last at least 10 years, right? Ideally forever.
Yeah. And they're in the -8 range, airbag inflators. So there's actually two types of airbag inflators. I'll just go through it real quick. One is pyrotechnic, and one is essentially a charged canister of compressed gas. For the pyrotechnic, if moisture gets into it, it can explode randomly. You could be driving down the road, and the pyrotechnic inflator could make your airbag blow up. So that's obviously really, really bad, right? Leaks on the other type of inflator, that's a pressurized gas cylinder. If that leaks and you get in a crash, there's no gas to inflate your airbag. So that's really, really bad too, right?
Yes.
And if you look at industry, there's a really good business case for having control over your leak testing process, so you don't have millions of recalls and your business doesn't fold. Takata.
Yeah, they are definitely challenging. And still have challenges. So we talk about large parts. So large parts are sometimes unwieldy, difficult to, maybe a higher leak rate that would be allowable, but because of the difficulty of using a pressure decay or mass flow technology, we might look to use a tracer gas technology. What are some applications specifically, large parts that come to mind for you based on your
so a good one is commercial air conditioning heat exchangers. These have fins and tubes, and at the end of each tube there's a braze joint, and then at the other end of the tube there's a braze joint. So when you get into these bigger heat exchangers, you could have a heat exchanger with 200 braze joints. So you can do that with a sniffer, but you have to rely on your operator to put the sniffer probe on, 200 or 400 different braze joints. And are they going to always do that? We know human error is a thing, even with the most attentive person, right? Sure. And B, that takes a long time. With sniffing, it's generally recommended that you're 2 seconds a joint. So if you have a huge heat exchanger with 400 braze joints on it, that's 800 seconds worth of sniffing, not counting any other part of the process. So that might make sense to be in a chamber rather than sniffing.
Yeah, good point. Of course, as we approach this 12 o'clock hour or right on it, so we've got battery technology. Of course, that's huge these days. EV is just exploding. So we've got a tremendous amount of experience with Cincinnati Test Systems and using these different technologies. Fuel systems, of course, everything is going higher and higher pressure to help meet the emission requirements, right? The higher the pressure, the better the atomization of the fuel as it burns inside the cylinder. So that's why we continue to escalate in the pressures. I'm sure there's more reasons. That's just my layman's understanding of why we continue to increase fuel systems pressures. Aluminum wheels is another example of just an application that's every day that you're like, oh my, I didn't even think about the fact that we would use helium or tracer gas to detect those. What am I missing there?
As far as tracer gas applications, the big ones are, refrigeration and air conditioning is huge. A lot of automotive components that you did a good job laying out here. It's everything. Missiles get tracer gas leak detected, like ICBM missiles. So it's all sorts of things.
Thank goodness.
Yes.
All right.
Yeah, a lot in the nuclear industry uses tracer gas, as you can imagine.
No doubt. Well, Matt, it's been a pleasure. I look forward to having more and more of these conversations with you over time. We always ask our customers if there are specific applications that you would like to know more about, more of, then please don't hesitate to let us know. Russ at CapExSales.com, Matt at CapExSales.com, Chris at CapExSales.com, Vicky at CapExSales.com. Just reach out to us. Let us know if there's a topic that you would like to know more about. We'll do some research if we're not subject matter experts, and we'll share that knowledge with you. So always looking again just to add value to our customers. So next week, though, we will be talking about the latest in the HVAC technologies, and specifically the new gas types that are being required. So explain a little bit about what we're going to be talking about next week, man.
Yeah, I'm gonna talk just a little bit of the state of the industry, what the trends are as far as what's happening. The home appliance market is going gangbusters right now. Indoor air quality is a big topic. Probably what we'll spend the most amount of time on is the move to more environmentally friendly refrigerants that have less impact on climate and pollution. The downside to those are that they are flammable, which you can imagine dealing with that in a factory presents some challenges.
Absolutely, yeah, for sure. So super excited about what is that refrigerant called? What's the name of R?
Oh, there's lots of different types, so I'll kind of go over that next time. Yeah, it depends on the application.
All right, fantastic. So we'll really look forward to that conversation. So as always, we want to thank each and every customer that we have. We are grateful. We're blessed to have you. We don't take you for granted. Matt Matheny is supporting South Carolina as well as Western North Carolina. You're going to be focusing there. Chris Mullins in Eastern North Carolina and Virginia. We welcome questions. Please just list them below here on the YouTube channel. We post this everywhere to try to again add value to our customers. So again, Matt, welcome aboard. Thanks so much for your efforts today, and we'll be in touch.
Yeah, thank you.
All right, thanks everyone.